Okay, 4.6, isosceles or equilateral triangles. Okay, so there's 4.6. So your new vocabulary today, the legs of an isosceles triangle, well, you know your base angles are always equal. Your legs must be congruent. Okay, the vertex angle is the one that's at the top, the one that's not congruent to the other two, unless of course obviously it could be an equilateral triangle, but if it's an isosceles, the vertex is the third angle. And then obviously finally your base angles, they're the ones where the two angles are both equal to each other. Here's the theorem that proves it. Okay, if it tells you that you've got two congruent sides, then you must have by default two congruent angles. And again, don't forget this word converse. We heard it the other week. All right. If you've got two angles that are congruent, then by default your two sides must also be congruent. Okay, so let's have a look at this isosceles triangle theorem. Again, what you've been given, what have you got to prove, all right? And again, don't forget you are going to use the reflective property again and the information that you've been given. But what I want you to pay close attention to is this guy here. Okay, what does CPCTC stand for? Its corresponding parts of congruent triangles are congruent. In other words, if you can use SSS, SAS, AAS, ASA and all that, then everything else, if you prove that two triangles are congruent, every other part of it is. Okay, so we can prove this by SSS because don't forget it tells you here that LM is congruent to LP. It also tells you that N is the midpoint, so we know that these are congruent, and this is the reflective property again. So we can prove that LNM and LNP are congruent by the side-side-side theorem. So that means that everything else must be congruent. So angle M must be congruent to angle P by this corresponding parts of congruent triangles are congruent. Okay, so just like the isosceles triangle, equilateral or equiangular triangles are the same. Okay, let's have a look at the diagram. For a start, all three angles ABC are congruent, and side AB, BC and AC are congruent. So one's either equilateral or equiangular. And in example 2, you can use that information to find the rest. For a start, you also know, what does it tell you? It's an isosceles triangle, so if that's the case, then this angle and this angle must equal the same. Okay, so that's the only thing you do know. It's an isosceles at the moment, that's all you need to find out. If it is, then you've got, as it says here, the 180 degrees, subtract the 60, you're left with 120. So angle Y and Z must equal 120, they must be the same size, both of them 60 degrees. So even though it's starting off with an isosceles triangle, you've proved it's actually an equilateral. So here's question number 3. How are you going to answer question number 3? Well, three angles must equal 180 degrees. You've already used 120 here, so you're going to subtract 120, so you know that angle H must equal 60 degrees. Similarly on here, you've got your three parts that says they're congruent, so that means that the measure of the three angles must also be congruent. So in theory you can write 3x equals 180 degrees, so x must be 60 degrees. Okay, let's be careful with questions similar to this. All right, even though by the definition of the fact that you've got AB and AC are congruent, then you've got an isosceles triangle. In that theory then, the two base angles must also be congruent, so this angle here must also be 2x. Well, the moment you see that, you know you've got an equilateral triangle, which then determines the fact that this guy must also equal that, and that's how they've solved to find out what y is. Okay, so again, looking at what you've got, they put that 4y minus 5 equals 3. They're solving to find y equals 2. You can plug it back in to make sure it's correct. 4 times 2 is 8. 8 take away 5 will give you 3, so that proves that. Okay, and again, it's equiangular or equilateral here. 6x equals 180, x is going to equal 30 degrees. Several ways of doing it, they did it slightly different. Let's have a look at question number 5. What do we do know? That angle S and angle T are congruent, which means that SR must also be congruent to RT. So we can take that as 2z minus 15 must equal 9. So 2z is going to equal 24. So z is equal to 12. Okay, 2-column proofs. All right, you know that your first statement is given. So here's all your given statements. And then you've got to prove this guy at the bottom. Well, let's have a look at the proof. Well, let's have a look at what we've got. For a start, we know that these two guys are congruent. So we've got a side. What else do we know? We know that EB bisects ABC. So that means by that given statement that this and this angle must be congruent. So we've got side angle. Do we know about, can we do angle side angle? Well, we don't know anything about angle A or C, but we do know, and again we're using it, there's our reflective property. So we've got side angle side, and there is your final reason to prove that triangle ABE is congruent to CBE. All you've got to do now is fill in the gaps along here. Well, let's have a look at what we've used. We've used the fact of we've got a bisector. Okay, what else did we use? We also used the BE. So we've got the reflective property. Okay, so start building up this statements and reasons on the right hand side. Basically that's it. There is another one here that they use in the reflective, not the reflective property, the definition of a bisector. So do we need that? No, we can get away with that, doing that one. So